All right, so let's continue our lesson, and we will now be talking about solving inequalities using addition and subtraction. And so our goal will be to use subtraction and addition in solving inequalities. Now, if you would remember, we have what we call as the addition property of equality when we were talking about equations, and that also applies with inequality, but this time it's now called the addition property of inequality, wherein any number that you add on one side of the inequality needs to be added also on the other side of the inequality to preserve that inequality. Okay, so let's say we have this example: x minus 15 is greater than 12. We have to find the value of x, and we also need to graph the solution. So just like the same goal that we had with solving equations, we need to isolate our variables. So you have x minus 15 is greater than 12. So our goal is to isolate our x, and so we have to work with the opposite operation of minus 15, and so that will be plus 15. So that will become 0. And remember, whatever we add on one side of the inequality, we also have to add on the other side. And so this inequality now becomes x is greater than 12 plus 15, which is 27. So this is our inequality. Now we are not done because we are asked to graph our solution. So always remember, when you do your graph, you have your number line. Your reference will be 0. 27 is on the right side of 0, so mark it somewhere there. Now, our inequality is a regular greater than, so that will be a hollow dot on 27, and our arrow is pointing to the right. So that is how our graph would look like. Alrighty. So why don't you try this next example on your own? Go ahead, solve for n, and do the graph. So to solve for n, we have to isolate our variable and we have to use the opposite of minus 5. So we add 5 on both sides of the inequality. And so we will have negative 3 and positive 5. That's going to be positive 2. So we have an expression n is less than positive 2. And so if you graph it, 2 will be on the right side of 0. We will use a hollow dot, and our arrow is pointing to the left. Okay, now if you're going to take a look at this example, we have our inequality 10 is greater than or equal to x minus 3. Okay, so now if you would remember, we prefer having the variable on the left side of the equation. Now it's up to you if you would like to switch it up already at the beginning so you don't get confused or you don't forget about it, or you can also do it later on once you have your value for x. Okay, so let's just stick to whatever we are given. Let's isolate our x, and for us to be able to do that, we need to get the opposite of minus 3, so that will be plus 3. And we add 3 also on the other side. So now we have 13 is greater than or equal to x. Okay, so now that we have this expression, like I said, it's a lot easier to do the graph, not confusing if you have your variable on the left side of the inequality. And so we can switch it to have x is on the left, 13 is on the right, and you can see the pointy end, okay, is towards x. So your inequality will switch. So now your expression becomes x is less than or equal to 13. And if you're going to do your graph, again, our reference is 0. 13 will be on the right side. Now this is our inequality is now greater than or equal to, and so we will be using a solid dot, and we are looking at all the values to the left of 13. Okay, so let's have another example. So this one, try this on your own. Go ahead, try it out. So if we are going to get the value of m, you will have m is greater than or equal to 9. 9 is to the right of 0. It's going to be a solid dot on 9, and it's going to be pointing all the solution to the right of 9. Okay.